Press the toilet handle, water rushes into the bowl, and everything disappears within seconds. But have you ever wondered where it actually goes? Does it flow directly into a river? Does it remain underground? Or is it cleaned and reused? In this video, we will follow wastewater from your home, through underground pipes, into a treatment plant, and finally back into the environment. When you flush a toilet, the wastewater travels through a pipe connected to your building's drainage system. Wastewater does not come only from toilets. It also comes from showers, bathroom sinks, kitchen sinks, washing machines, dishwashers, hospitals, schools, restaurants, businesses, and industries.
This wastewater may contain human waste, food particles, soap, grease, chemicals, microorganisms, and many other materials. Gravity usually moves the wastewater through underground sewer pipes. These pipes are installed at a slight downward slope, allowing wastewater to flow away from homes and buildings. In places where gravity alone is not sufficient, wastewater pumping stations collect the wastewater and pump it to a higher elevation or toward the treatment plant. In cities and large communities, wastewater normally enters a public sewer system. Small pipes from individual homes and buildings connect to larger street sewers. These street sewers then join main sewer lines that transport wastewater from thousands of properties to a centralised wastewater treatment facility. Manholes provide access to the underground sewer system so that workers can inspect, maintain, and clean the pipes. However, not every home is connected to a municipal sewer network. Homes in rural or low-density areas may use septic systems instead. In a septic system, wastewater from the house enters an underground septic tank. Inside the tank, heavy solids settle at the bottom and form sludge. Oils, grease, and other light materials float to the top and form a layer called scum. The liquid wastewater remains between these two layers. The liquid then leaves the septic tank and enters a drain field, where it slowly passes through pipes, gravel, and soil. The soil provides additional filtration and helps remove some contaminants before the water reaches the groundwater.
Unlike a septic system, which treats wastewater on the property where it is produced, a public sewer system transports wastewater to a centralised treatment plant. When wastewater arrives at the treatment plant, the first stage is called preliminary treatment. During preliminary treatment, wastewater passes through large metal screens. These screens remove objects that should never have entered the sewer, including wet wipes, plastics, pieces of cloth, sanitary products, sticks, and other large debris. Even products labelled as flushable can create serious problems. Many wipes do not break down as quickly as toilet paper and can combine with grease to block sewer pipes, damage pumps, and interfere with treatment equipment.
After screening, the wastewater may enter a grit chamber. In this chamber, the flow is carefully controlled so that heavy materials such as sand, gravel, eggshells, and small stones settle to the bottom. Removing grit and large debris protects pumps and other machinery used during the later stages of wastewater treatment. Next, the wastewater enters large tanks called primary settling tanks or primary sedimentation tanks. Inside these tanks, the wastewater moves very slowly. This allows heavy organic solids to sink to the bottom, where they form a thick material called primary sludge. Oil, grease, fats, and other floating materials rise to the surface. Mechanical scrapers remove the floating material from the top and collect the sludge from the bottom. Primary treatment removes a large amount of suspended material, but the water is still not clean. It continues to contain dissolved organic waste, nutrients, microorganisms, and very small particles that cannot be removed by simple settling. The wastewater therefore moves to secondary treatment, where microorganisms perform much of the cleaning. In a common process, known as the activated sludge process, wastewater enters a large aeration tank containing bacteria and other microorganisms. Air or oxygen is pumped into the tank, creating bubbles and helping the microorganisms remain active. These microorganisms feed on dissolved and suspended organic waste. As they consume the waste, they convert it into simpler substances, additional microorganisms, carbon dioxide and water.
After the required contaminants have been removed, the water is disinfected. Disinfection destroys or inactivates disease-causing bacteria, viruses, and other microorganisms. Treatment plants may use chlorine, ultraviolet light, ozone, or another disinfection method. Chlorine is a powerful disinfectant, while ultraviolet light damages the genetic material of microorganisms and prevents them from reproducing. After treatment and disinfection, the cleaned water is called treated effluent. Treated effluent is usually released into a river, lake, ocean, or another receiving water body. Before it is discharged, it must meet environmental quality requirements designed to protect public health and aquatic ecosystems. In some communities, treated wastewater is reused.
But what happens to the solid material removed during wastewater treatment? The sludge collected from primary and secondary treatment is also processed. One common method is anaerobic digestion. During anaerobic digestion, microorganisms break down organic matter in a sealed sludge digestion tank without oxygen. This process reduces the amount of organic material, decreases odours, helps destroy pathogens, and stabilises the sludge. Anaerobic digestion also produces biogas. Biogas contains a large proportion of methane, together with carbon dioxide and small quantities of other gases. Because methane contains energy, the biogas can be collected, cleaned, and used as a fuel. It may be burned in an engine or turbine connected to a generator, producing electricity for the wastewater treatment plant. The heat produced during electricity generation may also be recovered and used to warm the digestion tanks or buildings at the facility. This combined production of heat and electricity helps reduce energy costs and transforms waste into a useful renewable energy resource.